right, so I want to talk about a couple of things just so that everybody knows what's going on from now on. First of all, I put the new course schedule out on the home page of Blackboard for this class. So this is week 9. Last week would have been week 9, but of course we skipped it. So this is week 9. That means our semester is going to only have 15 weeks now. So week 15 is going to be finals week. So we just moved everything back a week, and then I condensed a couple of things in the last unit. So this unit isn't going to be much different than it was going to be in the first place. One big difference is that your week 9 notes, which some of you had already done, are not actually due until tonight. So those are due tonight at midnight. After that, we're going to go back to the same basic schedule that we had before. So your week 9 problems will be due Friday, the homework and the other assignment you have, let's see, which there isn't one actually. So your My Math Lab homework will be due on Saturday, and then your week 10 notes will be due on Sunday. Now that I look at this, I'm seeing typos I didn't realize were in there. For next week, everything will be back to the regular schedule. So your notes for next week will be due this Sunday night. The week 10 problems will be due Friday. The My Math Lab homework and that verifying identities card sort in Desmos will be due on Saturday. And then the week 11 notes will be due next Sunday. So we'll go through the same schedule after we get started this week. And since I'm working from home in my home office, you may get to hear my cat. So anyway, that's Oscar that's meowing. When we get around to it's testing time, so when we get to week 12, you'll be doing your exams online. So we'll talk more about that as we get closer to it. But for that, I think at this point, I think what we're going to do is that you're going to have your tests in either in My Math Lab or in Blackboard. And they will not be proctored since it's a little bit hard to get the proctors worked out for everybody. So they won't be proctored, but you will have to do something like taking pictures of your work and sending it to me afterwards. So like I said, we'll have more details about that as we get closer to it. I'm still working on some of those things. So this is in the week 9 folder on Blackboard. This is the first item that you'll come to, and it is kind of giving you all the details about what we're doing now. So we're still going to have the live sessions Monday, Wednesday, Friday from 10 to 10:50, just like we did before. It's just now they'll be online. We can do the same things basically that we were doing in class before. So we can talk about your questions from the notes, your questions from the problems or from My Math Lab, and we can look at whatever activity is due for the week. If you have a chance to join these sessions, I think that'd really help you. But I will record them, or I'll record at least portions of them if it's anything I think would be helpful. And then I'll post the recordings in the weekly folder. Now I'm going to have a class session right after this also, so I may not get these recordings posted until a little bit after noon after we have them. So don't expect to see them at 11 o'clock because I probably won't be able to get them up that quick, but probably by noon they'll be up there. If you need help at different times, I already had online office hours, so I'm still going to do that. Those are at the times that I listed for my office hours in the beginning. So that's 10 to 11 on Tuesday and Thursday, 5 to 6 p.m. on Monday and Wednesday, and then also from 3 to 4 on Thursday. So there are links to the office hours in the course homepage. And if none of those things work for you, if you have other questions, please just contact me. You can either email me or send me a message through Blackboard. We can talk online through Collaborate if you want to. If you call my office phone, I will eventually get the message, but I have to call specifically and check those messages, so I'm not going to walk into my office and see that I have a message. So that's probably the worst way to contact me if you really need to get a hold of me. The best way is to email me on my college email address. One thing that it says in here about turning in your weekly notes and problems, that's still going to be the same thing that we were doing before, but a lot of you had been emailing me with those and sending them as email attachments. That got really hard to keep track of. I had different emails coming in from different people, and things were in danger of getting lost. So please, if you possibly can, use the blog to turn those in. You can do the same thing in the blog, just make it an attachment in your blog entry, and that's lots easier for me to find them all if they're all collected in the blogs like that. If you absolutely can't get that to work in the blog, you can send it as an email attachment, but if you're having those kind of problems, please contact me so that we can get that worked out. The other thing is, if you don't have access to a computer or a tablet you can use, or if you don't have internet access, please let me know so that we can find a solution for that. We're doing this one. This was in the notes, and this comes from those sum and difference identities. So the thing is, with a lot of these is just to recognize what pattern there is. This looks like the pattern of one of the sum or difference identities. And since it's got cosine, cosine, and sine, sine, since the functions are together with their own kind, that means it's a sum or difference identity for cosine. That's the first thing that you can look for. If it were an identity for sine, it would have cosine and sine and cosine and sine. But if it's got each function together with its own kind, then it's for cosine. The other thing for the one for cosine, the sign switches, the plus or minus sign that is. Since this is a minus, that means it's going to be a plus. So it's actually the sum identity. So this one tells us that it's the sum identity. But then we're looking at the angles. We've got 4 pi over 15 and 11 pi over 15. So that means that this is going to be cosine of 4 pi over 15 plus 11 pi over 15. So we're just taking the two angles, and since we decided it was a sum identity, we're adding them. So then you can go ahead and, these already have a common denominator, so you can go ahead and add these together. That's going to be 15 pi over 15. You can cancel the 15, so that ends up being cosine of pi. And cosine of pi is -1. For a lot of these, what we're doing is looking for some kind of a pattern. So for these ones where it's one of those identities written out, that's what you need to do, is identify which one it is first, whether it's sine or cosine, and then figure out the plus or minus sign that's going to be in here. If it's an identity for cosine, then this switches. If it's for sine, it doesn't switch. All right, so in any of these where we're looking at identities, one of the big things is to be able to simplify things. One of the ways that we can do that is if we have other functions besides sine and cosine, we can write everything in terms of sine and cosine. A lot of times then we'll be able to cancel things or put things in some other form that we can see what to do with them. So for example, for this one, we've already got cosine here. If we want to write tangent in terms of sine and cosine, this is one of those identities that you need to know. It's one of the quotient identities. And that is that tangent theta equals sine over cosine. So we would use that one here. In place of tangent, we would do sine over cosine. And then we have that times cosine of theta. Remember, with all these, if you have any kind of rational expression, you can always write something like this over 1. So we've got a cosine on the top and the bottom. We can cancel those. So we just end up with sine of theta over 1, or just sine of theta. Let's look at this one over here, since this one's a little bit more complicated. This does make you deal with fractions somewhat, so you have to remember how to deal with those. Cosecant is the reciprocal of sine. So this is one of our, what I call the reciprocal identities. And that is cosecant theta equals 1 over sine theta. Remember, for these, to remember which one's which, is that you switch the letters on the front. So cosecant goes with sine and secant goes with cosine. So you switch from an S to a C on both of those. The other one we're going to want to use here is the other quotient identity, since we've got cotangent. That says that cotangent theta is cosine over sine. So taking both of those and rewriting this whole thing, we would have 1 over sine theta in place of the cosecant of theta, and then cosine theta over sine theta to take the place of the cotangent theta. Now what we want to do is simplify this big rational expression, so we're going to take the bottom of this and invert it and multiply. So we want to flip this and make that multiplication. So that's going to give us 1 over sine theta times sine theta over cosine theta. Now we can cancel the sign since we've got 1 on the top and 1 on the bottom. That gives us 1 over cosine of theta. And if we want to rewrite this as simply as possible, that would be the same as secant of theta. This is another one of our reciprocal identities to go from this to this. So actually, let's go through some of these fundamental identities. I know I did this in the notes, but this is going to be really important for you to just recognize when you've got some of these things. So let's go through some of these again. So the Pythagorean identities, there are 3 of those. The biggest one is that sine squared theta plus cosine squared theta equals 1. And of course, this can be written in the other order, so it can be cosine squared minus sine squared, or cosine squared plus sine squared, sorry, equals 1. And another one is tangent squared theta plus 1 equals secant squared theta. And the third one is that cotangent squared theta plus 1 equals cosecant squared theta. These two, notice they both follow the same pattern. This one has tangent, this one has cotangent, this one has secant, this one has cosecant. So this one is just like this one, only it has cofunctions. So if you can remember this one, then this one is just the same thing, only it just has the cofunctions instead. For these 3, you also need to recognize when you've got another form of any of these. So that's what we were talking about down here. Let's say that you had something where you had 1 minus cosine squared theta. That's just an alternative form of this identity. If we subtracted cosine squared from both sides, then that would give us sine squared. So there's an alternative form of that first Pythagorean identity, or we could also do 1 minus sine squared theta. That's going to equal cosine squared theta. So these are things to look for, or if you have a place where you have either sine squared or cosine squared and you want to rewrite it in terms of the other function, then you can use this, either one of these two going this direction. We can do the same thing with these other two identities. Another form of this one would be that tangent squared theta equals secant squared theta minus 1. Or we could even do tangent squared theta, or we could do, let's see, secant squared theta minus tangent squared theta is going to equal 1. And we could do the same things with this one. So these are all just things to look for. Pretty much anytime you have one of your trig functions squared, think about those Pythagorean identities. Then for the reciprocal identities, these are the ones I was talking about where the letters change. So secant is 1 over cosine. Cosecant is 1 over sine theta. And cotangent is 1 over tangent theta. So that one we don't really have a rule there, but not any time in any of these do we have the same letter starting the two functions. It's always a different letter. If that helps you remember which one goes with cosine and which one goes with sine, then that's a good thing. For the quotient identities, tangent is sine over cosine, and cotangent is cosine over sine. If you can remember these three sets of these identities, these are really the important ones. For the negative angle ones, those aren't quite as important because those we can work out other ways, but these ones and these, just be on the lookout for anything where you can use those. And also the alternative forms of some of those Pythagorean identities also. Other questions? I guess another thing I can tell you about this, I tell my calculus class this a lot because we do actually a lot that has to do with some of these trig identities and trying to figure things out. And the main thing to do if you're trying to simplify something, just start trying something. You might try something and it doesn't look like it's going to work. You can always go back and try using a different identity instead. But the worst thing that you can do is just leave it blank. If you don't know what else to do, change things to sine and cosine. Look for things where you've got something squared like this one. That means that you should be able to use one of those Pythagorean identities. If you have things like this with rational expressions, then change everything to sine and cosine and try and simplify them. So just the main thing is just try something. There's nothing wrong with trying something for a little bit and then going back and trying something else. All right, there's one other thing that I want to talk about. And I did a video for this already, but I just want to show you where that is in here. This assignment isn't actually due till next week, but you probably are going to want to get started on it this week. So this Trig Identities card sort, this is in Desmos. So this PDF just tells you about the activity. It is worth 30 points. That's why I gave you a couple of weeks to get it done. So you're going to go here and click on this to join it. The idea of this is just to help you with the idea of verifying identities. So this first screen kind of explains what you're going to be doing. And this first identity, you have one screen where you sort the cards, and then the next screen actually gives you the answer. So go ahead and try this, but the idea is to just figure out what you're doing with this. So these cards you can drag around. You always want to take the one with the actual identity highlighted in yellow and put that one first. And this next screen on this first one, if you get stuck, you can go here and look and see what the stack is supposed to look like. The other part of this is that for each one of these identities, after you get done with the card stacking, then you're going to go through and actually type in the whole identity proof here and give your explanations. So for the explanations, you can just say what you did, like here we factored out sine squared, or you can say which identity you used. If you used one of the Pythagorean identities or one of the quotient identities or one of the reciprocal identities, then you can just put that in there as your explanation for that step. So in this one, there are 8 identities altogether. This first one you have the answers for, so it shouldn't be too hard. There are 7 other ones that you will have to figure out for yourself. So I'm expecting it to take you some time. Again, that's why I gave you 2 weeks altogether to get it done. I would really recommend that you get started on it this week. And that way you'll have lots of time to ask me questions if you need to. And going back to this, I did make a video for you. I kind of go through some of the stuff I just talked about, but in a little bit more detail. So if you get stuck and you need some help, then go ahead and watch the video. It explains things in lots of details. And then if you're still stuck after that, then feel free to ask me questions. I don't know how easy this is to use, but if you guys want to do some kind of a study group, we can actually set up groups in Blackboard, and you can have your own discussion board, you can have your own collaborate sessions. If you guys want to do something like that, just let me know. Or you could always do something else like Zoom or something. But one of the nice things about the collaborate sessions is that you can use like a whiteboard. Some of those options are in there. Or if you have other ideas, I'm open to lots of suggestions.